Thank you very much. I really appreciate invitation to this meetup, Elizabeth. So it's an amazing opportunity. And I want to tell you some stuff about DuckDB. Just for explanation, my name is pronounced Josef Machytka. I'm from Czech Republic, from Europe, currently living in Germany and working here. And my slides will be shared later in chat, so you can download them. There are many information. I will not talk about everything in those slides, just those highlights. The intention is that you can later use those slides also offline. So let me start. Something shortly about me. I work currently as professional service consultant at NetApp Open Source Services, and I focus mainly on Postgres database. But since I worked in previous years in different startups, I had opportunity to work with many different technologies and many different databases, as you can see. And lately, I did also some talks on Postgres conferences. You can find slides on ResearchGate or on Academia Edu, and I regularly publish articles about Postgres and DuckDB also on medium.com. So here is a link to my profile. So, as Elizabeth already mentioned, DuckDB became very popular in 2024. Here you can see graph from Google Trends showing growing interest of people in this tool. And also stats of my articles on medium.com confirm it. I was quite surprised how quickly they gathered like hundreds of views and reads. So it is currently really very interesting tool for many people. And therefore, I want to show you some most important use cases which are useful for us as Postgres people because they can greatly enhance our ETL tasks and data analysis. Here is what I want to cover, and you will see some AI-generated images on some slides to make them more colorful. I created them with Deep Dream Generator. So to understand why DuckDB is interesting and where it is positioned, we must first talk about big data versus small data. We all heard about big data. I'm sorry. We heard about these 5 V's which characterize big data. And boom of big data was like a few years ago peaking, and it looked like a future will be all about bigger and bigger data sets, which we would need to process with some amazing new technologies. But over last years, many companies had to actually change their mind because their cloud costs skyrocketed, and they had to think twice about storing big data sets, and also GDPR and other law actually prohibit storing data indefinitely without clear use cases. So many companies realized that they mostly need aggregated results. And those aggregated data sets are typically only few dozens gigabytes or few hundreds of gigabytes. So we see it actually daily by our customers that the databases are not petabytes or hundreds of terabytes of data, but something much smaller. And also in these days, hardware advanced rapidly, so cloud instances can have even terabytes of memory. And it shifted our understanding of big data also very significantly. There is very nice article, Big Data is Dead, on motherduck.com, which highlights this situation. And this is why DuckDB team actually issued so-called Small Data Manifesto. And they argue that small data can be more useful and easier accessible than big data easier to process, sufficient for many use cases and for decision-making processes. And the biggest advantage of small data is that we can utilize them on our modern notebooks or on cloud instances, because on those big complex systems which process big data, users very often compete for resources. We see it also with big Postgres cloud instances that by some customers they are badly overloaded in some parts of the day. And this is the reason why thinking about processing small data locally become quite interesting for many people. Another topic which is important to highlight before I will talk about DuckDB itself are data formats. Because some 15, 20 years ago, world of data was mostly relational. We had relational tables, used SQL, everything was nicely joined. But today, we have real-time processing as a new norm. And those modern technologies, they use very diverse data formats. And it is impractical, or in some cases even impossible, to simply transfer these data formats into relational tables. So we must be able to work with these diverse formats directly. And there are some of them, we all know them. There are many others formats, but these 5 are probably most popular. In today's world of data analysis and computation, we must be able to work also directly with these formats. And this is what DuckDB actually offers. So let's look at DuckDB and its possibilities. First of all, DuckDB is not just another project of some enthusiast which would die in half a year because someone would be pissed off because of something. DuckDB was created a few years ago by people from National Research Institute for Mathematics and Computer Science in Amsterdam. And it has in these days even its non-profit DuckDB Foundation, which should ensure long-term maintenance and development. So it looks promising, looks like this tool is here to stay with us at least few next years. And it was created by people who were heavily utilizing SQLite and Pandas libraries. So it took a lot of stuff from this world and also from Postgres. So from our perspective, it's important that this is open source database. It is single node database, which is intended as embedded database for applications, just like SQLite, but it focuses on heavy parallel analytical workloads. And it uses columnar vectorized query processing engine, which can process data heavily in parallel. And it has very nice support for major languages, and it is also extremely portable. It does not have any external dependencies. So it is very simple to utilize DuckDB on whatever system you have available. For us, as Postgres people, it is important that DuckDB very closely follows SQL conventions from Postgres because it uses SQL parser, which was taken from Postgres. It also uses idea of custom extensions to add new functionality and implements multi-version concurrency control for transactions, similarly as Postgres does. Here you can see 2 main web addresses for resources about DuckDB. DuckDB.org is the main web page, and here is motherduck.com, which is a cloud installation of DuckDB. And here you can download for free this very interesting book, DuckDB in Action. I highly recommend it. There are many ideas, many recipes. As I said, it's single node database, which means that it is not designed for distributed environments, and it even does not have users in traditional way how other databases have them. Therefore, it also does not implement any permissions. at least currently. Maybe in the future we will see some forks. We will see. It's designed mainly for datasets fitting into memory, which could be in these days dozens or hundreds of gigabytes or even terabytes as I talk about those cloud instances. But I also successfully tested it with datasets much larger than memory. So I can say that it was built quite well and it can withstand a lot of load. Here on this picture, you can see where DuckDB positions itself regarding other databases. So we have traditional transactional databases, we have analytical databases, and we can think about them also as standalone databases and embedded databases. So as you can see, DuckDB occupies this niche of analytical embedded databases, which means it is not competing with any traditional database. It is really meant as enhancement for other databases. For some use cases, it's interesting to know details about DuckDB storage. Since it was created based on SQLite, it uses single file database format, but implements columnar storage, which is loosely based on Apache Parquet with lightweight compression, but it splits data into fixed size blocks. Default block size is 256 kilobyte. It can be configured differently, and this fixed size block was implemented for exactly the same reason as in Postgres, to allow in-place updates, deletes, and schema changes. For us, it is interesting as first use case because it packs all those tables in one data file, which can be easily shared between systems, and it's already compressed, and that compression is very efficient for numerical data. So it can even work better for data transfers than some more complex formats like HDF5 container, for example. For us, it's also important that DuckDB is prepared to work with whatever database is around available, because it implements all traditional database data types, including their many aliases, which we know from other databases or even from legacy systems. And since people who are using it work mainly with Python, it also can directly work with Python memory structures and also with Python data frames, as we know them from pandas or polars. When you download DuckDB, you will get one binary called DuckDB. And running this command or starting container with that command, you will start immediately both that engine and command line client. And that client feels very similar to PSQL. It even has its special commands. We have those backslash commands in PSQL. And this DuckDB client has dot commands starting with dot. So dot help will give you a list of all available dot commands. There are other commands modifying behavior of that shell, and dot exit or dot quit will end that client. As I said, it implements extensions for adding new functionality. So currently, DuckDB binary contains these 24 extensions, which allows you to work with MySQL, Postgres, SQLite, also work with different data formats like CSV, Excel, JSON, Parquet, or HTTP requests or data storages of main providers, and also geospatial data. But there are also many community-based extensions. On that duckdb.org page, you can find links to repositories or to lists of those community-based extensions. So environment around DuckDB is growing rapidly. well, those extensions have different degrees of maturity, and some of them will probably be abandoned, but this is normal way how it works with these systems. But it looks promising for future development. Just for you to know, I will not spend too much time here. It implements some very special joins, which can be very useful for some of you if you do some special types of data analysis. In Postgres, we have these three first bullet points. Those are joins which we know and love or hate in Postgres. But DuckDB has this additional four different joins. Personally, I like this idea of as-of join, which is actually intended for time series data. And it joins time series on the nearest timestamp, which could be very useful for some types of analysis. And now that when we know most important details about DuckDB, let's look how we can connect DuckDB and Postgres. In Postgres, we of course have our well-known foreign data wrappers to connect for external data sources. So there is DuckDB foreign data wrapper, but this tool allows us to only connect to existing DuckDB database file and work with tables in that database file. It is not possible to use it for embedded analytical processing. This wrapper is quite mature, although I encounter some problems with compilation and work with some versions of Postgres. For using DuckDB as an analytical or ETL engine, we need to look for other extensions. Currently, there are mostly discussed these two, pgDuckDB and pgAnalytics. They both aim to use DuckDB as embedded engine inside Postgres to run all queries and ETL tasks using DuckDB, but inside Postgres. Also, they are meant as a tool for connections with the data lakehouse architecture, because DuckDB implements connectivity for Apache Iceberg, Delta Lake, and other formats. But currently they are only in the 0.2 versions and seems to be not exactly ready for production. So from my perspective, it is better to use directly DuckDB and work with Postgres data from DuckDB, because it is remarkably easy. When you start DuckDB, you can, before you first use it, install and load Postgres extension. And there is attach command, which allows you to attach whatever remote Postgres database you have accessible, either specifying credentials here directly in that attach command, or first creating temporary or persistent secret and later using that secret in that attach command. And that attach command contains, here you specify local alias for that remote database. And then you can work with Postgres tables exactly the same way as you would be working locally. You just address those tables using that local alias, schema name, table name. So these three components, as we know them, for example, from MS SQL Server, which allows cross-database selects very easily. And this gives us first very interesting use case, beside of creating tables remotely or selecting them. And that very interesting use case are cross-database joins. Because you can attach different Postgres databases of different versions. Here I created example. I started in Docker 3 different versions of Postgres, 13, 14, 15. Created some example of users, orders, and products, and distributed these tables between these databases. And just using those local synonyms without specifying anything about those tables, do not need to create any foreign tables or whatever. Just using those tables in select, I can seamlessly combine data from all these databases in one select and get result. And the same way, I could add also different MySQL databases because it has currently direct support for MySQL, Postgres, and SQLite embedded in that DuckDB binary, and it would work exactly the same way. So if we want to look further and use data analysis and ETL, DuckDB can offer us a very powerful functionality. I created some examples, probe measurements and user data, generated uh, always two different CSV files for both tables. First of them fitting into memory, 10 gigabytes. Second, 100 gigabytes, not fitting into memory on my testing machine with 64 gigs of memory, and started to test them. First finding was that if tables are fitting into memory, it is very easy to process them remotely. But if those are large tables, which are much larger than available memory, it is better to either copy them to DuckDB or, in my case of this example, using directly those CSV files. And I can use directly data files because DuckDB implements table functions API. So you can select data directly from data file. Here is example of Parquet format. If those names are standard and can be recognized based on extension, it can be addressed this way, or if you need to use some non-standard name or some additional parameters, there are always reading functions. So you can run whatever SQL commands you want, of course, not updates, deletes, but selects and other aggregations and window functions directly on data from that data file. So this gives us also possibility to very easily import data into Postgres using DuckDB, because we simply attach that Postgres database, and we can create table in Postgres as select from that CSV data file. So here I created directly table in Postgres, selecting data from that CSV data file, which had 100 gigabytes. And I did not need to create any table structure or check structure of that CSV file. DuckDB recognizes this automatically. In case of CSV file, you can even select from compressed data file. If you would have CSV.gz, DuckDB will understand that this is compressed data file and will decompress it on the fly. So it gives us very nice possibilities to speed up our ad hoc ETL tasks, because as you probably all know, importing CSV file into Postgres ad hoc could mean a lot of manual work, even some detective work about structure. But DuckDB recognizes everything automatically, creates table based on data types which are in that file. It could be used also for other data formats. If they are not available as standard extensions, we can use very simple Python code. Here is example with pandas, because it's like traditional library, but in these days we would use more modern Polars library, which allows much bigger data sets. So here I created example to read a legacy DBF file for old DBase, XBase legacy databases, because I learned that on some institutions they still use them. And they have them as original data source, but they have problems that these data files are not readable by modern databases, because simply developers do not believe that anyone is still using them. But this simple code, which reads data into data frame, Python data frame, and uses DuckDB as embedded database engine, and run SQL commands inside that embedded DuckDB database, it allows us to simply import that DBF file into Postgres because I attached Postgres database and I create table in Postgres as select from that data frame. This is a nice example of that tight integration between DuckDB and Postgres because we read data here into data frame, and inside DuckDB we are addressing that data frame in SQL command. And with all these components, we can also do very quick conversions between data formats using DuckDB. In these days, world is heading towards Parquet format. Parquet format is de facto standard for Delta lakes and data lake houses. Because Apache Iceberg, Apache Hudi, and Delta Lake architecture are all built on the top of Parquet format. So we may need to convert our older data files or some legacy databases into Parquet format, and we can easily do it using DuckDB because here again we can save a lot of manual work. DuckDB uses this copy command as we know it from Postgres. It is exactly the same syntax, exactly the same usage. So we can use copy command to read from CSV file and convert data directly into Parquet format. Or as I showed on previous slide, that example with data frame, we can first read data with some Python code and create Parquet file from that data frame. We can also copy data from some Postgres table into Parquet format, or using community extension for Avro format, we can easily convert Avro into Parquet without knowing anything about its internal structure, data content, or whatever. And of course, the same magic works also for export into CSV and JSON format. I love this because it can simplify a lot of work. But we have also very powerful data analysis commands in DuckDB. It has very advanced implementations of aggregations and window functions. In some cases, even more interesting than in Postgres, but the core is exactly the same. Here I want to highlight just these three commands: summarize, histogram, and pivot, which are actually not occurring in Postgres. And these can have very quick analytical results, either from tables or directly from data files. So here is example of summarize command. Here I did it on a table, which was stored locally in DuckDB, but I can do it also directly in that source CSV file. And as you can see, it gives us basic statistics for each column. So we see minimum, maximum, average, if it makes sense, standard deviation, some quantiles, count of rows, and amount of nulls, percentage of nulls. And here you can see that DuckDB utilizes machine almost up to the maximum. I tested on machine with 20 cores. And when I was running this summarize command on that local table or on a CSV file, as you can see, it was used very heavily. And here is statistics of run. So a result was delivered in some 2.5 minutes. And this total runtime of all CPUs shows heavy parallel usage. I can do it also remotely with a remote Postgres table. But in that case, characteristic will be different because it must read first portions of data and process them. So it will be slower, it will take longer, but it will work definitely for tables fitting into memory without problems. There is also this histogram command. It produces currently a Python map memory structure, so I must do some magic with those map entries and unnest them and put in them separately. But the main part of that command is very simple. And on that big table, which was created from that CSV file with 100 gigs of 100 gigs of data, which had 1.4 billions of rows, it created that histogram in 4.5 seconds, utilizing all cores very heavily. So it is very efficient, very quick. Imagine what we would have to write manually in Postgres to get these results from summarize or get these results from histogram. And there is even third command, which would mean in Postgres either heavy manual work or utilizing some extensions for pivot tables. And even with those extensions, it would not be trivial. But here in DuckDB, we have this nice pivot command, which allows us to group results, to use whatever aggregations we need. Of course, we must think about properly limiting results in number of columns and number of rows, which would produce, because without proper boundaries, it can explode into dozens or hundreds of pivot columns and millions or billions of rows. And in that case, I tested that situation. DuckDB would try to do its best, but it will totally overload the machine and it can fill disk because of many temporary files. And the same stuff can be done directly on those data files. So here I show summarize from that CSV file and pivot of data from that CSV file. A very nice implementation. And last use case, which could be very useful for us for our daily work, is the usage of DuckDB as a rudimentary migration tool. It already has implementation of MySQL, Postgres, and SQLite connectors. So first example is about migrating a simple table from MySQL into Postgres. I created this example, which uses some MySQL specific data types. I inserted data and migrated that table from MySQL to Postgres simply by attaching MySQL database, attaching Postgres database, and running create table in Postgres as select from MySQL table. Of course, this is just rudimentary migration. It will not migrate any primary key or constraints or indexes or foreign keys or whatever. But for very simple snapshots, like some daily snapshots of database or some ad hoc backups, it can be very useful. We could also argue about this default casting of those specific data types, but for, as I said, for ad hoc stuff, it is saving a lot of time. And if we need to migrate data from some other databases, here is a very simple example from for MS SQL Server using that Polars library. In this case, I copy data which fits into memory, so I can do it in one take, reading data into Polar's data frame and running inside embedded DuckDB database, first attaching Postgres and then creating table in Postgres as select from that data frame. And this is the whole migration. It will do conversions of data types automatically, conversions of data if necessary also automatically. And if we would want to migrate a much bigger table, which will not fit into memory, we just need to do it in batches using cursor. So here is another example. Big table, which we need to process in batches. And the only difference here is that we need to first read schema from the data frame for Polar's library to work properly. But otherwise, everything is done again inside DuckDB. We just insert data in batches. So I promise that my talk will be like half an hour. So it took 33 minutes. I hope it's okay. Here is just a very short summary of those use cases which I showed you. It's just, first taste of possibilities of DuckDB. There are many other very interesting things about DuckDB, but it would be for different talks. And hopefully we will see a huge progress in development of new features, and also those extensions in Postgres will be soon available to be able to really embed DuckDB into Postgres. So it is very interesting tool, can save us a lot of manual work. And I thank you very much for your attention. I hope that talk was informative and interesting for you.